all wanted to get away from people. Our neighbors can be annoying, our family crazy, and interacting with customers at work can be too much. But few have taken it upon themselves to avoid people so much that they live in extreme or harsh environments. And no, I'm not talking about Alaskans, I'm talking about extremophiles. Extremophiles are organisms that live in the most remote and extreme places on Earth, where few other organisms live. Every day, we touch things, we eat food, we high-five our friends. Everything in our life revolves around microorganisms, so let's discuss the most extreme kinds of these. Today, we will talk about what are extremophiles, what make them so extreme, and what potential do they hold for humans. The word extremophile is made up of two words, extreme and phile, which means lover. This refers to their love for extreme environments. All extremophiles are made up of two types of cells, either prokaryotic or eukaryotic cells. Prokaryotic cells are single cells that have no nucleus and free-floating DNA. Eukaryotic cells are multicellular and have a nucleus that contains their linear DNA. Most extremophiles come in prokaryotic form, such as thermophiles, which are archaea and live in extreme heat, or the bacteria psychrophiles, which live in extreme cold. Eukaryotic extremophiles are known to us as fungi or tardigrades, which live most everywhere on Earth. Now that we know what extremophiles are, let's discuss what makes them so extreme. According to the researcher Heather Beale, thermophiles or heat lovers live in hydrothermal vents or in hot springs such as in Yellowstone National Park. They can survive up to temperatures ranging between 140 to 284 degrees. This is because of their enzymes, extremozymes, can withstand extreme heat without collapsing like our human ones would. And the researcher Caviccioli studied psychrophiles and said that they live in Antarctic ice or glacier water. They can survive here because they have cold shock proteins which regenerate their DNA structure, and also because they are able to keep their cell walls flexible when ours would become rigid. They thrive in temperatures ranging from -11 to 68 degrees Fahrenheit. According to the microbiologists William Miller and Bob Goldstein, tardigrades, otherwise known as the water bear because of their cute bear appearance, have 4 sets of legs, are transparent, and range in size from about 0.5 millimeter to 1 millimeter long. The researcher Carolina Chavez said that tardigrades are able to survive extreme dehydration and radiation by going into hibernation, which they can survive in that state for up to 30 years. This is why they can survive space. Now that we know what makes them so extreme, let's talk about the potentials that they hold for humans. Heather Beale discussed that thermophiles have already been useful in DNA fingerprinting, which allows forensic scientists to identify someone based off of their DNA. Psychrophiles, according to the research of Pouranami Guthrum, have made textiles more durable to cold temperatures. They also make it easier to take lactose out of milk and make it more energy efficient to produce wine and cheese. The genetic scientist Hashimoto discovered that mixing tardigrade DNA with human cultured cells makes the cells more resistant to radiation. Now that we've discussed what extremophiles can do for humans, I will sum up what we've learned. We've learned what are extremophiles, what make them so extreme, and what potentials they hold for humans. Next time you pick up some sand, dirt, or snow, remember extremophiles. They're microorganisms living their best lives in the most unlikely of places. Thank you.